back to Chemistry 1407, Lab 7, Fermentation of Sugar. So, before getting into fermentation of sugar, what is this lab about? Let me talk about a little bit of the background. So, all human beings, including all the living organisms, need energy molecule named ATP to run all the cellular process. Now, ATP is the energy molecule, so the more ATP gets produced, the more energy we get. So where do we get the ATP? Of course, the source is our food. Now, the whole process of producing the ATP from food is called respiration. Respiration can occur with oxygen, that is aerobic, and without oxygen, anaerobic system. So, in aerobic system, the glucose from the food that we get reacts with the oxygen, giving out carbon dioxide and 38 numbers of ATP molecules. So, this aerobic respiration, this 38 ATP, this process happens in 3 steps. First one is glycolysis, which produces 2 ATP. Second one is the Krebs cycle, producing 2 ATP again. And the rest, 34 ATP, the last step is called electron transport. But what happens when there is no oxygen? So an aerobic system, the glucose there doesn't, it gets break down to pyruvate and only produces 2 ATP. So it doesn't go beyond the glycolysis cycle. And the pyruvate transforms to lactic acid. Well, that happens when we exercise a lot, right, Ms. White?
Yes. So when you're working out, you're trying to lift weights or do cardio, you're using a lot of energy. So what happens is your body is using up a lot of the oxygen that you're inhaling. At some point, you don't have enough oxygen to sustain the reaction. So your body goes into this anaerobic reaction, producing pyruvate. Pyruvate becomes lactic acid. This deposits in your joints. And next morning, you wake up, you're walking like this. Not because you're buff, it's because your joints are hurting.
Right. And when this happens in human body, other organisms like yeast, what happens to yeast? So, without oxygen, the glucose breaks down to an alcohol, the ethanol, to carbon dioxide, gas molecule, and only produces 2 ATP molecules. So you see here, without the oxygen, in yeast, the glucose or the sugar breaking down to an alcohol, that's why we say it's a fermentation of sugar. So the lab is all about this process, this reaction. As in the lab, we don't have a procedure to actually measure up how much of ATP gets produced, but from the reaction, we see that the mole-to-mole ratio, or how many carbon dioxide gas gets produced, is exactly saying of how many of ATP molecules gets produced. So what we will do is use different types of sugar, like sucrose, right?
Yes, sucrose, lactose, galactose, maltose, even honey, high fructose corn syrup in your experiment. And what we're going to be doing is figuring out how much ATP is being produced by each sugar.
So, what we're going to do is measure the volume of the carbon dioxide gas produced. From there, figure out how many molecules or moles of carbon dioxide we get, and the moles of carbon dioxide gas will be as same as the ATP molecules produced. So, what we can say is this fermentation of sugar. This is the gist of it. So we're going to using yeast, and to see for different types of sugar actually gives you different amounts of energy.
Right.
I guess the sucrose is the standard.
It's the standard of experiment, right?
Yeah.
And so if you look at your lab protocol on page 4, it tells you if you assume sucrose to produce 100% ATP, then you're comparing the different sources of sugar or different sugars and their percentage. So for sucrose being 100%, glucose is actually only 74% of what sucrose will produce. So say you were going to run, say you're an athlete, and you wanted a lot of energy. It'd be better you to have sucrose than glucose because you get more ATP from sucrose.
More energy.
Yeah, more
But
energy.
if we want to go on a diet,
The other way around.
exactly. So you do understand. That's how the difference is. If we choose different sugar, that's how we get different amounts of energy. So that's about the gist of the background on the lab.
So the one thing I want to add here is, since the yeast is a living organism, when given a choice, it will actually prefer to go through the aerobic route.
Exactly.
Now we as scientists are going to force the poor yeast to go the anaerobic route. How are we going to do that? When we put them in the bottle, we'll put oil over their heads. Well, they don't really have heads, but on top of them. And putting oil over them will block any oxygen from coming in.
Exactly.
So though they want to go this route that makes 38 ATP, they'll be forced to go this route. If you're above 18 and you're making alcohol, because you're above 8, no, my bad, it's 21. If you're above 21 and it's okay for you to make alcohol, you will follow the same process and force the yeast to make alcohol. If you're baking, that's legal at any age. You force the yeast to make carbon dioxide. That's what makes the bread rise. Okay? But our goal here is to make this ferment. So we will not give the yeast any option but to go through the anaerobic step to make our ATP. And so it should be a fun lab.
Yeah. So that's the lab. So start of the procedure. Let's weigh out about 1 gram of sucrose. Let me put the pan right here on the weighing balance, tare it so that we can get only the mass of the sucrose. Let me try to get 1 gram. There you go. About 1 gram of sucrose. Let's take the pan and let me put it. I have already labeled it as sucrose, SUC. And let me put this right here. Now, I got a little bit of spilled a little bit. Now, and now we need yeast solution to be added to this sucrose. So we need hot water at least at 35 degrees Celsius temperature. We have here water around 35 degrees Celsius temperature. Now we need 125 ml of it in a beaker.
Okay.
Let's measure this out. In the meantime, let me weigh out about 2 grams of yeast. Let me tare it. There we go. We have about 2 grams of yeast. Let me add it to the water. And we need to stir this water. We need to stir this well, and also make sure that sometimes you take the temperature because the temperature needs to be around 35 degrees Celsius. Make sure to mix it well. Now we're going to need about 6 ml of this yeast solution, and we'll add it to the sucrose. There you go.
Okay. Six
There you
milliliters.
go.
Pouring this into the sucrose bottle.
And let's add about 1 little bit of oil in it. So here's
Oil.
the oil.
So the oil, let's see.
It needs to be
Are we
about
supposed to
half
mix
cent-
that?
No.
Okay. And then we're gonna add half a centimeter. Okay. And then it says be careful not to mix it. So
Very carefully, gently we're going to create an oil layer. So the oxygen, we cut off the source of the oxygen. There you go. So this is how we created an oil layer. So now, let me insert the dropper. So this is how, see the oil layer at the top? Okay, now let me put the top of the dropper. Okay, now we're gonna set up, when this reaction is happening, the carbon dioxide gas getting produced, we're gonna set up that tube.
So we're about to attempt the setup. Please make sure that your beaker is the one that has the water. So we took out the yeast solution and put it in a styrofoam cup, because this is a lot better to put the warm water in there.
Yeah, and make sure it is on 35 degrees Celsius temperature, because the temperature is important. If it's not at 35 degrees Celsius, the reaction won't happen.
Right.
So it is at 35 degrees.
It's at 35, and then you want this one also at 35. This is where we're going to be placing the yeast solution in the bottle in that small one. So don't fill this one out. It's also around 35, so we should be good to go. Now I'm going to take this and pour some of the water in here. Oh, I'm going to pour it right here. And you want to try to fill this up as much as possible. And then we will insert the hose. Oh, insert the hose, yeah, real deep. That's what I did last time. Okay. And then you want to hold your thumb over it like this. And so we fill this part out because we realize that if it's not filled, it's hard to actually get this into it. So like that. Let's see how we did. Yay, we did well. Very good.
And then attach the other end of the tube to the dropper end of this.
Oh, there, okay. It has to snap on.
So let's attach the...
Yeah.
Okay.
The
Now
little
let's
lid on
attach
this has to snap on. So.
Snap on. Completely closed. Other end of the tube goes at the dropper end. And let's put the sucrose each solution.
Okay.
Why we're doing this? We're doing this to keep it at, all of the system at 35 degrees Celsius.
Which is around the body temperature.
Yes.
So the idea is once the solution is immersed in the water, the solution will have the same temperature as the water. So the yeast will be at 35 degrees Celsius. And then the gas collected will also be at 35 degrees Celsius. So you're supposed to take a reading of the volume every 15 minutes for 60 minutes.
Yes.
And this is the end of the setup.
And so this is the setup.
So you have enough yeast here to actually do a total of 5 experiments. And they want you to have 6 runs, but you're using the sucrose twice, right? So you're provided with lactose, you're provided with starch, mineral oil,
The oil to create the
layer,
glucose,
glucose, and cellulose.
and cellulose.
For our first run, we're supposed to be using the sucrose, lactose, what's the other one?
And the glucose.
The glucose, yeah, that would be your first run.
And the second run, they wanted you to repeat the sucrose with the cellulose and the starch.
Right. And the reason why you're separating them is because of the materials you have. You only have 3 setups. So you're doing the exact same setup 3 different times for 3 different sources of sugar.
Also, based on the different types of molecules, starch and cellulose are polysaccharides. Much bigger molecule than glucose. So, different sugars will give you, with the reaction, different volume of carbon dioxide. That should direct you to different, how many numbers of ATP gets produced.
And this is the lab.